Let us do section B of practice paper 1. This section also has 20 questions, out of which you have to answer 16 questions. Question 21. If the function f of x equal to 2x squared minus kx plus 5 is increasing on the closed interval 1, 2, then k lies in the interval. The function f of x is 2x squared minus kx plus 5. Let us find f dash of x, which is 4x minus k. The function is said to be increasing in the interval a comma b when f dash of x is greater than 0 in the interval a comma b. Therefore, 4x minus k should be greater than 0. That is, 4x is greater than k, which is k is less than 4x. And we know that x belongs to the closed interval 1, 2. That is 1 less than or equal to x less than or equal to 2. Let us multiply throughout by 4 to get 4x. 4 less than or equal to 4x less than or equal to 8. The least value of 4x is 4. Therefore, k should be less than 4. Because the least value of 4x is 4, k is less than 4. Less than 4 means it can take any real value between minus infinity and 4. Option A is the correct answer. Question 22. Domain and range of f of x equal to absolute value of x minus 3 divided by x minus 3 are respectively. This function is a signum function. Domain is the set of possible values which x can take. And range is set of all possible values which f of x can take. Now the given function is absolute value of x minus 3 divided by x minus 3. The denominator should not be 0. So x minus 3 cannot be 0. So x cannot take the value 3. Other than 3, x can take any real value. Therefore, the domain of this function is r minus 3. From the whole real number set, only 3 is excluded. Now let us find the range. F of x is absolute value of x minus 3 upon x minus 3. If x is greater than 3, x minus 3 will be positive because x is more than 3. So for positive values, we need not write the absolute value sign. Therefore, the function becomes 1. And for all x values which are less than 3, absolute value of x minus 3 upon x minus 3 becomes x is less than 3, so x minus 3 will be negative. For negative values, we write minus of x minus 3 to remove the absolute value sign. Therefore, this value is minus 1. Now we can write the range of this function. For all real values which are more than 3, the function takes the value 1. And for all real values which are less than 3, the function takes the value minus 1. The correct option is B. Question 23. If f of x is 1 minus cos 10x by x square when x is less than 0 and a when x is equal to 0 and root x upon root of 625 plus root x minus 25 for x greater than 0, then the value of a so that f of x may be continuous at x equal to 0 is. We have only one unknown quantity for f of 0, which is a. So we can find LHL or RHL. Any one will be enough for this question. And if you calculate both will give you the same answer. Let us do LHL. Limit x tending to 0 minus. For 0 minus, we use less than 0 definition, which is 1 minus cos 10x upon x square. Let us use the trigonometric formula. 1 minus cos 10x is 2 sine square half of this angle, which is 5x, divided by x square. Limit x tending to 0 minus 2 sine 5x by x the whole square, I can write it as. Since we have sine 5x in the numerator, I need 5 in the denominator. That is, we have divided by 5 square. So let us multiply by 5 square. Now we will apply the limit formula, limit extending to 0 of sin x upon x is 1. As x tends to 0, 5x also tends to 0. Therefore, the formula is applicable here. We get 1 square times 25, which is 50. Even if you do RHL, by rationalizing the denominator of the function for x greater than 0, we will get the same answer, 50. And it is given that the function is continuous at x equal to 0. So RHL, LHL must be equal to f of 0. So 50 is equal to f of 0 is a. So the value of a is 50. B subdivision is the correct answer. Question 24. If matrix A is 2, 3, 5, minus 2b such that A inverse is Ka, then K equals. Let us first find the determinant value of A, which is minus 4, minus 15, minus 19. It is not equal to 0, therefore A inverse exists. And we know the formula for A inverse, which is 1 by determinant of A into adjoint of A. 1 upon the determinant value is minus 19. Adjoint of A, it is very easy to write the adjoint of a 2 by 2 matrix. We interchange the diagonal elements and we change the sign of the non-diagonal elements. We get the adjoint. Now this is 2 over 19, 3 over 19, 5 over 19, minus 2 over 19. This is equal to K times A. To multiply a matrix by a scalar, we multiply each and every entry by that scalar K. When two matrices are equal, the corresponding elements must be equal. Let us equate these two. So 2k is 2 over 19. Therefore, k value is 1 divided by 19. B option is the correct option. If you equate the other entries, you will get the same answer for k. If you don't get the same answer by two different equations, you will write k not defined. Here, from all equations, you will get the same value for k. Therefore, option B is the correct answer. Question 25. If x raised to y is equal to e raised to x minus y, then dy by dx. This is an implicit equation, that is x and y are together. X raised to y is e raised to x minus y. Here both base and power are variables. If both are variables, we need to use logarithmic differentiation. Let us take log on both sides. Log of x raised to y is log of e raised to x minus y. And this is y log x using the logarithmic formula. And here x minus y, log e is 1. Log e to the base e is 1. We have to find dy by dx. So let us collect y terms on one side. And x remains here. Y is common. Now y is x upon 1 plus log x. The given equation was in the implicit form. Now we made it an explicit equation. If we differentiate this explicit equation, we will get the answer in terms of x and we will get dy by dx directly. Let us differentiate using the quotient rule. U by v the whole dash is u dash v minus uv dash upon v square. U is x, u dash is 1, into v is the denominator, minus u is x, and differential of log x is 1 by x, divided by v square, 1 plus log x the whole square. 1 plus log x minus 1 upon 1 plus log x whole square. The answer is log x upon 1 plus log x the whole square. The correct answer is C. Let us do question 26. Matrices A and B are given, both are 3 by 3 matrices, and the product AB is I, the identity matrix of order 3. Then x plus y equals. Let us multiply these two matrices. Matrix multiplication is not commutative, so write in the correct order, A first and then B. Both are of order 3 by 3, so the answer is also of order 3 by 3. Let us multiply the first row with the first column. 1 plus 2 times 0 plus x into 0. And then first row into second column. Minus 2 plus 2 and 0. First row into third column. Multiply the corresponding elements and add 1 into y plus 2 into 0 plus 1 into x. We need not calculate the other elements. And it is given as the identity matrix. Identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1 of order 3. Now by equating the corresponding elements, we get x plus y equal to 0. The answer is A subdivision. We need not multiply the other rows and columns. Even if you multiply, you will get 0, 1, 0, 0, 0, 1. Question 27. If the line y equal to x touches the curve y equal to x squared plus bx plus c at a point 1, 1, then we have to find b and c values. It's given that the curve is touching this line at 1 point 1, 1. The curve is y equals x squared plus bx plus c and the tangent line is y equal to x. At the point 1, 1, slope of the curve and slope of the tangent should be the same. Y equals x is the tangent. So slope of the tangent is dy by dx. Differentiation of x is 1. Curve equation is y equal to x squared plus bx plus c. Dy by dx of the curve is 2x plus b, but at the point of contact, slope of the tangent will be equal to slope of the curve. So 2 into 1 plus b. Slope of the tangent at the same point, 1, 1 is the same constant 1. Both should be equal. Therefore, b value is minus 1. Now to find c, we will use the curve equation. Point 1, 1 lies on this curve. So 1 is equal to 1 square plus b into 1 plus c. We know the value of b minus 1. Therefore, c value is plus 1. B is minus 1, C is plus 1. B option is the correct option. 28th question. Evaluate cot inverse of minus root 3. We know the principal value branch for cot inverse, 0 to pi. For positive values, first quadrant angle we get. For negative values, we get the second quadrant angle. Cot inverse of minus root 3. We can write this as pi minus cot inverse of root 3. Pi minus cot inverse of root 3 is 30 degrees, pi by 6. Pi minus pi by 6, let us take LCM, 6 pi minus pi. The answer is 5 pi by 6. B option, which is 5 pi by 6. Question 29. The function f of x is absolute value of x minus 1, where x belongs to the real number set R. Then we have to check the continuity and the differentiability of this function at x equal to 1. We all know about the absolute value function. It takes V shape, the graph. Here the function is absolute value of x minus 1. Equate the function which is under the absolute value sign to 0. X is 1. The turning point of the graph is at 1. So from the figure itself, we can make out that f is a continuous function. There is no break in the graph. Even at 1, it is continuous. but it is not differentiable at x equal to 1. Why? Because as x approaches 1, the slope on the right hand side of 1 is plus 1 because this is 45 degrees. And slope of this line on the left hand side of 1 is minus 1 because it is 135 degrees with the positive direction of x-axis. That is, our RHD at 1 will be plus 1 and LHD at 1 will be minus 1. So they don't approach to the same value. Therefore, it won't be differentiable at x equal to 1. Or you may check the continuity by LHL and RHL and f of 1 and differentiability by LHD and RHD. It is a continuous function at 1 but not differentiable at 1. The correct option is B. Next question 30. Let X, A, B, three matrices are given. If AX is B, then X is equal to. It is given that AX is equal to B. Let us substitute these matrices. A is 1, minus 1, 2, 2, 0, 1, 3, 2, 1 times X matrix is X, Y, Z equal to matrix B, 3, 1, 4. From this equation, X is A inverse B. So we can find A inverse and multiply with B, you will get X matrix. But that is a longer method. So easier method is, let us multiply these two matrices, X minus Y plus 2Z equal to 3. And the second equation will be 2X plus 0Y plus Z equal to 1. Third equation will be 3x plus 2y plus z equal to 4. Now substitute the given answers and check which one satisfies all the three equations. Let us substitute the first A subdivision. X is 1, y is 2, z is 3. First equation will be 1 minus 2 plus 6. We don't get 3. Therefore, A option is not correct. Let us go for B option. For B option, x is minus 1, y is minus 2, z is minus 3. So the first equation will be minus 1 minus of minus 2 plus 2 minus 6. Here also we don't get 3. So second B option is also wrong. Now let us check the third option. X is 0, y is 1, z is 2. Plug in these values in the first equation. 0 minus 1 plus 4 gives 3. Don't conclude the answer as C. All the three equations should be satisfied because D also satisfies the first equation. See the D option. X is minus 1, y is 2, z is 3. The first equation becomes minus 1 minus 2 plus 6, which gives 3. So the first equation is true for C and D options. Let us go to the second equation. C option I am substituting 0, 0, 2 is not 1. It doesn't satisfy. Let us check the D option. Minus 2, 0 and 3 is 1. Yes. Third equation. So C option is not true because second equation is not satisfied. Now let us check the third equation for the last option. Minus 3 plus 2 twos are 4 and 3. So the answer is 4. Yes, correct. All the three equations are satisfied. D is the correct answer. Question 31. If A is a 3 by 4 matrix and B is a matrix such that A dash B and B A dash are both defined, then B is of the type. A is of order 3 by 4. A dash B is defined and B A dash is also defined. Let us take B's order as M by N. A dash is of order 4 by 3. A is of order 3 by 4. A dash is the transpose. We have to change rows into columns or columns into rows. So the order of A dash will be 4 by 3. And order of B, we took it as M by N. The matrix multiplication is possible only when the number of columns of the first is equal to number of rows of the second matrix. So M should be 3. Here, B A dash is also defined. B is of order m by n. A dash is of order 4 by 3. This multiplication is also defined when number of columns of the first is equal to number of rows of the second matrix. So n value should be 4. Now we said B is of order m by n. Therefore, B is of order 3 by 4. A option is the correct answer. Next question, 32. The derivative of cos inverse of 2x square minus 1 with respect to cos inverse of x is. This is an important question. Usually we do the differentiation with respect to a single variable, with respect to x, with respect to y, or with respect to t, or with respect to theta. Here we are differentiating one function with respect to another function. So the method is we will take the first function as u and the second one as v. We will find du by dx, dv by dx, and we will divide to get du by dv. That is differentiation of the first function with respect to the second function. Before doing differentiation, we can simplify this function by substituting x as cos theta. Without simplification also you can do, but it will be a longer proof. So cos inverse of 2 cos square theta minus 1. Cos inverse of 2 cos square theta minus 1 is cos 2 theta. Now cos inverse and cos will get cancelled. We get 2 theta. We will substitute for theta. Theta is cos inverse of x. Now v is also cos inverse of x. So we have to differentiate u with respect to v. So directly we can write the answer as 2. Because differential of 2 cos inverse of x with respect to cos inverse of x will give you 2. Or find du by dx. 2 times derivative of cos inverse is minus 1 upon root of 1 minus x squared. Similarly, we will find dv by dx. Differentiation of cos inverse is minus 1 upon root of 1 minus x squared. Now let us find du by dv, which is du by dx upon dv by dx. Minus 2 by root of 1 minus x square upon minus 1 by root of 1 minus x square. The answer is 2. A subdivision is the correct answer. Let's do question 33. If the set A contains 5 elements and set B contains 6 elements, then the number of 1, 1 and onto mappings from A to B is. N of A is 5. N of B is 6. Set A has 5 elements and set B has 6 elements. It is a 1-1 mapping. So for 5 elements, we will have 5 images. So one element is left without a pre-image. That means it cannot be an onto function. So if you have 5 and 6 elements in A and B respectively, we cannot have a mapping which is both 1-1 and onto. So it's not possible. The answer is C. We have 0 mapping satisfying the given condition. Question 34. The point on the curve y square equal to x, where tangent makes 45 degrees angle with x-axis is. This is a parabola. Let us differentiate to find the slope of the tangent dy by dx. Power has to be differentiated first, and then the base y has to be differentiated with respect to x. Equal to derivative of x is 1. dy upon dx is 1 upon 2y. It is given that the tangent makes 45 degrees. So we can find the slope of the tangent from this, which is tan 45. Tan 45 is 1. dy by dx is also slope of the tangent, so both must be equal. By equating 1 by 2y to 1, we get y equal to half. Now let us substitute y value in the curve equation. 1 by 2 the whole square, which is 1 by 4, is x. Therefore, the point is, write the x coordinate first and then the y coordinate. You may go wrong by writing the other way around, half, comma, 1 by 4. So be careful. The correct option is B. Question 35. If x lies in the interval, closed interval 0 to 1, then the least value of x squared plus x plus 1 is. So least value is the minimum value. And the interval is closed. The domain is a closed interval. So it becomes absolute minimum question. We have to find the absolute minimum of this function. So even if the word absolute is not mentioned, if the domain of the function is a closed interval, you have to find the absolute maximum or absolute minimum of that function. Here it is least value, so absolute minimum has to be calculated. Let us take y as x squared plus x plus 1. Differentiating both sides with respect to x, we get 2x plus 1. Let us find the critical values by equating the first derivative to 0. We get x equal to half. But the interval given is 0 to 1. Minus half doesn't come in that domain which is given. So let us not take that value minus half because it is not in the domain. Since we have to find the absolute minimum, we take f of 0 and f of 1 values and compare, because we don't have a critical value. Otherwise, we have to calculate the value of f at the end values of the domain and at the critical points. Here there are no critical values. So f of 0, 0 plus 0 plus 1, which is 1. F of 1, x square is 1 square plus 1 plus 1, 3. We have to find the least value of the function. The answer is 1, C option. Next question 36. If A and B are invertible matrices, what do you mean by invertible matrices? A inverse and B inverse exist. Which of the following statement is not correct? The first statement is adjoint of A is determinant of A into A inverse. This is correct because we know the formula for A inverse, 1 by determinant of A into adjoint of A. It is the same equation. So this is correct. Now option B is determinant value of A inverse is, we can write this as determinant of A whole power minus 1, which is 1 by determinant of A. This is also correct. D option, AB the whole inverse, the reversal law, B inverse times A inverse. This is also correct. Therefore, C must be incorrect. A plus B the whole inverse is not equal to A inverse plus B inverse. So this is the incorrect answer. So the answer is C. Next question 37. In a LPP, LPP means linear programming problem, the minimum value of the objective function z equal to ax plus by is always 0 if the origin is one of the corner points of the feasible region. The objective function is given as ax plus by and no other information is given. The constraints are not given and we don't know the values of A and B. Both may be positive, both may be negative, or one of them may be negative. So it all depends upon the values of A and B and in which quadrant the feasible solution lies. The question says the minimum value is always at 0, which is false. So B option is the answer for this question. Question 38. If the area of a triangle ABC is 3 square units with vertices A 1 3, B 0 0, C K 0, then K is equal to. We know area of the triangle formula, half into determinant x1 y1 1, x2 y2 1, x3 y3 1 equal to, the area is given as 3. So we have absolute value sign for this area formula. If we remove the absolute value sign, we have to write plus or minus 3. Whenever area of a triangle is given, don't forget to write plus or minus 3. If you write plus or minus 3, we will get 2 answers. By mistake, if you write only plus 3, you will get only 1 answer. And don't forget this half. These are the mistakes which you may do. So be careful and let us substitute. I will substitute 0, 0 as the first point, so expansion of the determinant will be easier. In any order, you can write the points, no problem. K, 0, 1. I'm taking 2 to the other side. 2 3s are 6. Let us expand this determinant along the first row. So 1 into, the first two terms are zeros. So 1 into the third term will be 0 minus 3k, which is plus or minus 6. Minus 3k is plus 6 is one equation. Minus 3k equal to minus 6 is the other equation. We get minus 2 and here we get plus 2. So k takes the values plus 2 or minus 2. D is the correct answer. Question 39. Let A be x belonging to z. Z is set of all integers. Z is 0, plus or minus 1, plus or minus 2, etc. And the question says that 0 less than or equal to x less than or equal to 10. So you have integers satisfying that condition. So 0, 1, 2, etc. up to 10. This is set A. And a relation A cross A is defined as R is equal to set of all A comma B such that A, B both are in the set A and modulus of A minus B is divisible by 3. Find the equivalence class of 2. We have to write the set of all elements which are related to 2. 2 is related to 2 because 2 minus 2 is 0, which is divisible by 3. And 2 is related to 5 because 2 minus 5, absolute value of 2 minus 5, absolute value of minus 3 is 3, which is again divisible by 3. And then 2 is related to 8 because absolute value of 2 minus 8 is 6. This is also divisible by 3. And then the next value will be 11. 2 and 11, but 11 doesn't belong to the set given set A. Therefore, 2, 5, 8. The correct option is A. If you write the equivalence class of 5, you will get the same elements because 5 is related to 2, 5 is related to 5, 5 is related to 8. So equivalence class of 8 will also be 2, 5, 8. So equivalence class of 2, 5, 8 will be the same. Question number 40. This is the last question of section B. The given function f of x is e raised to cos inverse of sine of x plus pi by 3. We have to find f of 8 pi by 9. Let us substitute x as 8 pi by 9. E raised to cos inverse of sine. We will simplify this. The LCM is 9. We get 8 pi plus 3 pi, which is 11 pi. 11 pi by 9 is a third quadrant angle. We can write this as pi plus 2 pi by 9. And let us use sine pi plus theta formula. In the third quadrant, sine is negative. So we get minus sine theta. We get e raised to cos inverse of minus sine 2 pi by 9. And this can be written as sine of minus 2 pi by 9 because sine of minus theta is minus sine theta. And we can change cos inverse to sine inverse because sine inverse of x plus cos inverse of x is pi by 2. Using this formula, it becomes pi by 2 minus sine inverse of sine minus 2 pi by 9. Now sine inverse and sine could be cancelled because minus 2 pi by 9 is in the principal value branch of sine inverse. We get e raised to pi by 2 minus of minus 2 pi by 9. So plus 2 pi by 9. Let us take LCM 18. we get 9 pi plus 4 pi, which is 13 pi. The correct option is B.